Hi, so a while ago I did a teardown of a BMW laser headlight which contained this module which uses a blue laser to excite a very tiny dot of white phosphor, producing a very, very small light source, something of the order of half a millimetre, something in that sort of order. The point of that being you can use that to generate a very tightly focused narrow beam. This is very difficult to achieve just with LEDs purely because of power density, so as you look at high power LED you tend to sort of see things like this which have multiple dye, so the heat's spread out over quite a wide area, and although it gives you high intensity and high power, it doesn't give you that tight beam. And I packaged this up into this torch or flashlight, as you say in the US assembly, and this will produce sort of very sort of tight narrow beam when it's at its tightest focus. Shining across the room, this is probably about a sort of 3 metre or so distance. It will produce a spot which is sort of the order of 50 millimetres, so sort of super tight. And I've been sort of passively on the lookout for similar sorts of laser, sources available as components for because reasons. And the only thing I've come across is this is made by Kyocera SLD. I think SLD are a company that Kyocera bought out. And this is a sort of similar type of thing. This is actually a sort of piece of white phosphor which has two blue laser diodes pointing at it. And I think there's also a version of this that has four blue laser diodes. This is normally a 500 lumen part. There's also a 1000 lumen part. And if you look at the structure, it looks like they probably just had sort of another two laser diodes because there's space in the package for that. And this will produce a spot size around a half millimetre according to the datasheet. So you've got obviously the sort of extremely intense white light source, but with a fairly small spot size. So it will cast sort of very sharp shadows. And this is rather expensive. I think this is about 70 odd pounds. I think this may have been used in a Lotus headlamp. I think I saw a press release to that effect. But obviously this is a very niche thing and sort of fairly expensive. And if you look at the structure, there's a close-up here. You can actually see the two blue laser diodes sort of diagonally pointing at the phosphor, and there's some metallization on the front glass, presumably to prevent the blue light escaping out of the front. Now, sort of hunting around on AliExpress, I came across this. This is about the only relatively low-cost sort of laser source that I've found, and this is blue laser diode at the back with a small piece of phosphor, and there's a lens at the front. Now, it does produce a pretty intense light beam, but it doesn't really have a very small source. So I'm not really sure sort of quite what the point of this is, or what it's even used for. A small lens at the front with a piece of phosphor. Now this is about, I'd say about 3 millimetres diameter, so it's not doing the super small spot size of either the Kyocera or the BMW device. There's a diffuser in the back just to diffuse the blue light from the laser diode. So you can see there's just some sort of slight diffusion. It's probably a bit hard to see on camera. And there's another sort of lens in the back of there, which is sort of focusing the laser into a fairly small spot. That lens in there looks like it's sort of fairly well stuck in, but say the back you can see there's just your normal two pins of the sort of TO, was it TO18 or the standard package that you see laser diodes in. So yeah, this is definitely a laser source, relatively low cost. I think it's about £40 on AliExpress, but it doesn't give that super fine small beam spot, so it does include an internal lens that you can probably actually assemble it without that, but even so you're still going to end up with a fairly large spot size, so not super interesting. And there are a few slightly different variants of this on AliExpress. Searching LEP laser module seems to get most of them. One word of warning, I can't see it at the moment, but there was a listing for this one where the headline price was actually quite low, about £6, but once you dive in you see there's like this selection. They usually describe it as colour for like different product variants, and that price was just for the phosphor disc and not for the whole module. So these are about sort of around the £40 sort of mark, but I'm not entirely sure what the application of these is. The thing I found sort of searching on AliExpress sort of laser LED was this was described as a laser LED headlamp module, but actually it isn't. This is just a sort of very high intensity LED with some optics to get a sort of a narrowish beam. There's another dip beam, one behind here, with some other sort of funky shaped optics, and a fan on the back of it. It's got two separate sources. It doesn't seem to sort of discriminate between pretty much any permutation of connections. Seems to just light up both of them in a vaguely semicircular beam. Probably okay if you want a nice bright source, but it's not definitely not a laser source. So quite a while later, I was just talking to one of my customers about these things and sort of showing him the Kyocera device and also this torch that I built up using the module out of the BMW headlight. And said, oh yeah, we got something like that from AliExpress. I thought that was interesting. So I had a hunt around and I found quite a lot of torches, flashlights with these devices, which are basically a fairly small circular device. These are all advertised as LED laser flashlight or various permutations of that. They're also implying that these were laser-based devices.
The laser.
Some of them with just completely absurd specs, like sort of 100 million lumens and 1,000 watt LEDs and all the sort of nonsense you get from Chinese listings. But with that source, you do get quite a nice sort of circular beam. If we just compare that with the one from the BMW thing, you can see the BMW on the right it is a bit smaller, but this does produce quite a nice sort of fairly tight circular beam. Again, this is at about probably 3 meters, and that's maybe sort of 200mm wide beam. So that's sort of quite interesting. If you compare this with the more conventional source, what you effectively get at the fine beam is just an image of the emitter. So most of these use a square array of multiple die. That was another one, but they all tend to sort of be square, and sometimes you can see the patterning on the die. I then sort of went down a bit of a rabbit hole just finding lots of these things. So there's this sort of quite nice tiny little one, which is quite a sweet little thing. And then at the more ridiculous end, I found this just completely ludicrous thing. The spot size is very similar, but it's a lot brighter, and this thing's absolutely just completely crazy. Power source in this is so ridiculous. You've got 8 18650s. These have been tabbed up into a parallel pair. It pulls about 5 or 6 amps on these, so I mean, okay, this will give you a good long battery life, but in terms of power, it's about, one of these pairs would actually power this quite happily. So this was like, I think £40 or something, not particularly expensive, but it's just, I completely underestimated the sizes when it turned up. I thought, what on earth is going on here? And this has actually got a USB power bank built in, so you can actually use it as power source. And these do have a pretty high power density. Even the sort of the medium-sized ones have no trouble at all producing sort of smoke from a piece of dark coloured paper. This big one will quite happily start fires in absolutely no time at all. So I was getting a bit curious as to what these so-called laser devices were. And so I started trying to find the source of the actual components themselves, and this took a long time. I eventually remembered that quite often when you're looking for LEDs as opposed to LED products on AliExpress, the word beads is quite effective as sort of components, bulbs, that sort of thing. So if you search laser LED beads, you actually start finding these components. So I ended up with a collection of these. There's a few different styles. The smallest ones, they're normally rated at 8 watts. Then we go up to this larger package, rated sort of around the 10 to 20 watt region, and then sort of at the highest end we have these which are 50 watt. Most of these are white, but there are some variants. For example, there's this one which is green, which is actually a green phosphor over the normal blue LED. And you can also get blue ones, which are just obviously the standard LED without the phosphor. Obviously I'm running this at very, very low power, sort of cranking this up to full power. It's pretty insanely bright, as you'd expect. And these are available both as individual separate devices or mounted on aluminium or copper PCB to simplify heat sinking. Now, sort of looking in more detail at the structure of these, all these white ones, these are basically comprise the die with a glass cover. These central discs are actually glass with like a silicone infill on them, whereas the larger ones are a sort of ceramic package with a sort of a glass cover over the entire part, obviously for the deal with the higher power dissipation. And I've sort of tried to a limited extent just pulling these apart and just see if I can get some idea of the structure. One thing that's very characteristic of all of them, they've got this pattern, this sort of die grid pattern, which sort of looking in more detail looks like these are interconnects to connect to a top layer of metallization, which is one of the electrodes. Then you've got this sort of layer of the lead material, which I've tried sort of scraping it off of some of the blue ones, and it does seem to be, it's not like lots of individual leads, it's almost like a homogeneous coating, and wherever you scrape it the blue sort of disappears. I don't know enough about the actual details of lead structure to know exactly what's going on there. And then there's some metallization along the bottom, some smaller wires that are just about visible, and then sort of thin metal layer at the bottom, then onto the ceramic packaging. And you can see a number of bond wires. So if you look, the structure of the white one is actually very similar to the glass front one. It's just it's buried in silicone, so you can't really see it as well. So obviously they're using glass at the front to because obviously the power density of this is so high that any plastic will probably just melt and burn. Yeah, obviously they need to be careful what materials are actually there, because say the optical power available there is so great. You can also see there's quite a number of bond wires. Say the highest power ones of these are about 50 watts, so you'd be looking at sort of about 15 amps of current going into those. As to whether these are actually lasers, I think that's highly unlikely. Two reasons for that. One is on a laser, what you tend to see is that as you increase the current, you get a very rapid rise in optical output as the laser reaches lasing threshold. And you don't see that with these. The output is reasonably linear as you increase the current, but also on the blue ones, there's no evidence of any sort of speckle pattern that you'd expect to see with lasers. Now, obviously, if it's a very large bunch of lasers effectively in parallel, they might perhaps all combine to make that speckle less obvious, but I'm not seeing any signs of any sort of discrete structures. For example, I know there are things called vertical cavity surface emitting lasers, where instead of the traditional sort of horizontal cavity that you see on most blue lasers and other semiconductor lasers, the cavity is vertical in the die, but I think those are relatively large, and I've also only ever seen those on infrared. I'm not aware that those exist for blue lasers, so I'm pretty certain that this is probably some sort of relatively conventional LED type device, but with just maybe a slightly unusual physical structure just to get that very high power density. And what I find interesting is these don't really resemble any other LEDs I've seen from commercial manufacturers. The only thing I've seen that's close is this SFT12R device from Luminous, but even that's not quite the same. If you look closely, the pattern of the interconnects is different. It's like more of a rectangular grid than the sort of uniform spacing grid that we see on all these parts. All these have this sort of fairly uniform grid of these interconnects. You can see, even on the white ones, you can usually see it through the phosphor coating. And I've been trying to find any information I can about the source of these. I've done quite a lot of reverse image searches, and literally the only thing that comes up is AliExpress links. So, who makes these? They're clearly, all the same sort of structure. They're probably coming out of the same factory. But I'd love to know if anyone has any information or proper data sheets on these. All the AliExpress listings give you is, current rating, power rating, and you don't really know whether you can even believe those or not, because they're probably resellers rather than anyone connected to the actual manufacturer. But so I'm rather curious to know a bit more about these things, because they just seem to be like a little bit unique, and as far as I can tell, they're not sort of clones of or manufactured by sort of major manufacturers, as far as I can tell. I mean, perhaps they are, and they just, I don't know, for some reason just don't show up in any of the listings, but so it's a bit of a mystery. Just trying to think of some interesting applications for these. Because of the small spot size, it's very easy to couple this light into a fibre optic. You don't need lenses or anything. All I've done here is I've just butted the fibres up against the source and put some UV glue on it, so there's no air gap, and just secured it with a piece of wire. So you need to be careful not to have any black plastic sheathing or anything, because that will just melt because of the optical power. Because of the small source, you can do this quite easily with very little things, so you get an extremely powerful source at the end of the fibre. So this would be quite good perhaps for something like microscope illumination, or anywhere where you need to get a lot of light into a very, very small space without the local heating. And here's just some standard 1mm fibre, the sort of stuff that's used for like digital audio. You need to avoid having any of the black plastic sheath near the source, but I'll just use the metal coupler here. Again, just crank that up. You get just an insane amount of light from just this tiny little source. I'm sure there's some potential uses for like a super low cost high intensity fibre light source. Of course, as well as flexible sort of fibre optics, they also couple very nicely into light guides like this. Is just a piece of acrylic rod, so you get some quite cool effects. Lightsaber perhaps. One nice thing about the front of these being glass is it is a bit more resilient. So for example, if you do end up with some melted plastic, you can usually just scrape it off and it's fine, whereas the silicone coating on conventional LEDs is somewhat more fragile, so these are a bit more robust. What you can do that's quite interesting with the blue one in particular is that you can use sort of fluorescent materials, and the blue will actually excite that fluorescence, so you can get some interesting sort of colour effects, but also sort of a lot more light from the fact that blue is actually exciting the fluorescent material all the way through. This is actually some very slightly fluorescent material, but you get quite a nice sort of yeah, the blue actually looks pretty much white, and it sort of transitions to a sort of an orangey glow at the top. It's a bit hard to see on the camera. It's confusing the camera somewhat. It's a bit of a sort of pink fluorescent rod, and again you get some pretty cool effects. Let's just turn the current down a bit on this. You get sort of quite an interesting transition of colour on here. So some quite interesting and unique devices there. If anyone knows anything more about these data sheets, please link it down below. Also, if you come across any other available actual real laser light sources, that might also be quite interesting. But it'd be interesting to explore some other applications of these. Must be some application where like a very, very small, very intense light source might be of some use. But obviously the torches of the prime market, to which they're very well suited, producing this super narrow beam. But say it wouldn't be surprised me if there's some other interesting applications they could be put to.